Okay, let's look at some more examples. Okay, you're in sales for Vail Resorts selling weekend resort stays. You've sold 5 in your last 10 calls. If you call 3 people tonight, what's the probability of exactly 2 sales? So here's a case where I'm basically given the 5 out of 10 instead of the probability already, the percentage. Last problem it had 4% allergic to nuts. This is a case where you just have to do the 5 out of 10. So 50% is my probability of success. Number of trials is going to be 3 because I'm calling 3 people tonight. My number of successes that I'm interested in is exactly 2. So here's a case where I'm going to say false when it comes to cumulative in the binomial function. So equals binomial distribution, binom dist. Number of successes that I'm interested in is 2. The number of trials is only 3 this time, just 3 calls. And the probability of a successful call is 0.5. I could also have put just 5 divided by 10. So if you get, bigger numbers that are a little harder to work on, then you can just do that. And then for the cumulative, I'm going to say false because I just want the exact probability for exactly 2 successes. So 37.5% is that likelihood, okay, of exactly 2 sales. So let's say it's known that 38% of all ice cream consumers prefer chocolate. What is the probability that exactly 5 customers among 10 randomly picked customers will prefer chocolate? So my probability of success is 38%, and I want the probability that x equals exactly 5. So I'm going to put false for the cumulative function. And my number of trials, or my sample is 10, number of customers. Okay, so for the binomial function, binom dist, the number of successes that I'm interested in is 5. The number of trials is 10. Probability of success or preferring chocolate is 38%, so 0.38. And I'm going to say false because I want to know the probability of exactly 5, not less than 5 or greater than 5. Okay, so 18.3% likelihood of that. So A. All right, what is the probability that at least 5 customers among 10 will prefer chocolate? So here's a case where we want 5 or more. So basically, we're going to have to do the complement rule with 1 minus because this is a greater than problem. So, and I want to know 5 or more. Okay, so the complement is going to be 4 or less. So I actually want to put in 4 in this case when I do the binomial distribution function. Okay, so equals, I want 4. Number of trials is still 10. Probability of success is still 38%. And I'm going to say true this time, but remember I'm going to have to do 1 minus that to get the complement. I can either put the 1 minus in here, or I could have just done the binomial distribution function and then subtracted it from 1 after. Either way is fine. Just make sure you are saying true. For any less than or greater than problems, you're going to have to say true there. Okay, so just don't forget to do the 1 minus. And you can see it comes out the same. Okay. So for binomial, there's also a mean and standard deviation. The mean of a binomial random variable is basically just the number of people you have times the probability of success. So basically, if I have a classroom of 30 and the chance of them being allergic to nuts is 4%, I just take 4% of 30. And the standard deviation is this equation here. You can basically just put those in Excel. So let's ask this question, and then I'll do a demo within Excel on a different screencast. What is the mean for the chocolate ice cream problem? And the probability, just as a reminder, was 38% and sample size was 10. Another question, what is the standard deviation? Okay. And what is the mean for the nut allergy problem? Okay. Reminder, the probability of success was 4% and sample size was 30. Also, think about the standard deviation for the nut allergy problem. Okay, so let me go back. The mean is just the number of trials or sample size times probability of success, and then the standard deviation is going to be the mean, the n times pi, times 1 minus pi, but then don't forget to take the square root of that. Okay, so again, here's one problem, mean for the chocolate ice cream problem, and you can pause it if you want. Probability was 38% and sample size was 10. Basically 38% of 10, so 3.8 people. And this one I'll do a demo of in Excel.